Section 8.3, we're going to learn more about factoring trinomials, and we're going to do a little bit more with formulae. You might remember back some time ago, I might have given you something like A equals mg plus mt. I might have given you a formula with a whole bunch of letters in it like that. And I might have asked you to take that formula and solve for the letter t. What did that mean, to say solve for the letter t?
Get t by itself on one side.
You want to have t all by itself on one side, and you don't want to have any other t's over on the other side. All right, well, how did we do that?
Subtract mg from both sides and divide by m.
All right, we noticed that this t was right here. This is what we wanted to get alone. We noticed it was connected with some stuff that had some addition, and it was connected with some stuff that had some multiplication. So we did the opposites. The opposite of adding is subtracting. So we would subtract the mg on both sides. So we would have a minus mg is mt. Now, the t is only connected using a multiply. The opposite of multiply is divide. So we divide by m, and we make sure we do it everywhere. So our final answer would be t equals a minus mg all over m. Questions on that one?
And it would still be okay to like cancel out the m's if you want to write it that way?
If you want to cancel out the m's, you'd have to write this. You'd have to write a over m minus mg over m, and you could cancel out the m here. So another correct answer would be a over m minus g. But when you divide by that m, you have to divide everywhere. So the a has to be divided by the m. And that's a very common mistake. People will cancel the m's out here. You can't just cancel those m's out, because then the a is no longer being divided by the m.
So it's probably a better bet just to leave it like that.
Better bet to leave it alone. Yep, when you try to simplify, you make mistakes.
Okay.
Now, what if I gave you the same formula, a equals mg plus mt, and I asked you to solve for m? All right, I'm going to give you a wrong answer. This is what a lot of people will do. This is wrong, and we'll talk about why. I'm going to take this, a equals mg plus mt, and I'm going to subtract mt on both sides. So that gives me a minus mt equals mg. Then what? Well, this m is connected by a multiply, so I would divide by g. A minus mt all over g equals m. Now, actually, I haven't really done anything wrong. All the steps I did are actually legal and correct, but that's not the right answer. Why not? Didn't we solve for m? Don't we have m over here all by itself?
Yeah, but you need the other m.
The problem is I have another m over on the other side. When we say solve for m, we mean have m over here all by itself, but you're not allowed to have any m's over there. So while I haven't made any mistakes, I don't have the right answer. I don't have m all by itself. So let's do it right now.
Can you pull it up?
Yep. A equals mg plus mt. Any ideas?
Would you divide g plus t?
You could put m and then put g plus t in parentheses in front of it.
Exactly. So you're both correct. You're 2 steps ahead. You're doing one at a time. That's correct. What you need to notice is you're trying to solve for m. And what you need to see is there are 2 m's. When there are 2 m's and you're trying to solve for that letter, you need to factor. So look at this. You've got an mg and an mt. What's your common factor? M. They both have an M in them, don't they? So the first thing you're going to do is notice that there are two M's, which tells you you're going to factor. When you factor the M out, what's left over? G plus T. Now, notice we're trying to get this M all by itself, and this M is connected by a multiply. If M is connected by a multiply, how do you get the M all by itself? Do a divide. So the correct answer is A over G plus T equals M. Now I have M on the right hand side, all by itself, and I do not have any M's over on the left hand side. Questions on that? How come when I did this one the first time and I was solving for T, how come I didn't factor? There's only one T. If there's only one T, you don't need to factor. But if I ask you to solve for M, there are two M's, and that's what tells you you need to factor. So there's the big difference. Questions on that? All right, let's try one more of those. How about, I'm just going to make up a formula. I don't know if this formula really means anything. P equals 2LW plus 2LH plus 2HW. In fact, that one might be on the sheet that I'm passing out here in a few minutes. Close enough. Oh well, we'll do it anyway. What letter do we want to solve for?
No.
L, H.
Yeah.
Clever person would have said P. Why P?
Because it's already done.
It's already done. That's right. Solve for P. Oh, done. All right. Let's pick a different one. Solve for L, say. I don't think it really matters which one we do for L, H, or W. I think we get the same problem with all of them. Okay. Well, what do you see? I see two L's. I definitely see two L's. Those two pieces have L's in them.
2L out of that bad boy.
Not quite though. Because if I'm going to take 2L out, I really need to take it out of everywhere. Can I take a 2L out of here?
You
No.
can take a 2 though.
I could take a 2, that's true. I think I want to do something here before I factor this time. I want to move this over to the other side. I want to start by getting, if I'm trying to solve for L, I want all the L's on one side, all the not L's on the other. So I think I want to get rid of this thing first. This is connected by a plus, so I do a minus. So I think the first thing I want to write is P minus 2HW equals 2LW plus 2LH. So if I'm trying to solve for L, I get all the L things on one side, all the not L things on the other. So I do add or subtract as needed. Now I think I can factor, because looking at my right hand side, I think I have a GCF. What's my GCF? 2L. So I'm going to have P minus 2HW equals, I take out 2L, what's left over? W plus H. Almost done. How do I get, I only have one L written down now, that's a good thing. How do I get this one L all by itself? Divide by, I got to divide by the 2, because it's being multiplied, and I need to divide by the W plus H. So I think my answer is going to be P minus 2HW divided by 2 times W plus H, I have to divide by both of those, equals L. Questions on that one? Okay, so that's the part on formulas. Now let's talk about trinomials. What does trinomials mean? 3 things. That's correct. So So we've done some factoring of trinomials already. I might have asked you to factor x squared minus x minus 12. And you would tell me the answer is?
X minus 4x 3.
X minus 4.
4x plus 3.
X minus 4 and x plus 3. And I would tell you you're correct. Why is that the correct answer?
Because the two numbers add up to equal negative 12, or multiply to equal negative 12.
The two numbers multiply to be negative 12,
And they add up to equal negative x.
and they add up to give the negative 1x in the middle. That's correct. So, when we have factored trinomials up to this point, this first number right here has always been what number?
X squared.
It's always been an x squared. What's the number right in front of the x squared?
1.
Well, 1. It's pretty easy to factor trinomials when this first number is the number 1. So what are we going to do in this section?
Put a number in front of it.
Put a number in front of those. For example, I might ask you to factor. And I'm going to pick one out of the book here. How about 12x squared minus 17x plus 6? Well, here's the hard part. I'm going to put my parentheses here. And right away we're going to see how this gets very, very hard. How can I get 12x squared to come out in the front?
Take the square root of it.
Well, square root of 12 is not a nice number.
No.
You have to use the factor tree?
I have to use the factors of 12. So what are the factors of 12?
4 and 3.
So I could use a 4x and a 3x. That would give me a 12x squared. What else could I use? I could use a 6x and a 2x. That would give me 12x squared. Or a 12x and a 1x. That could give me 12x squared. Which one's the right one?
All of them?
There's the tree.
There's only one that'll work.
12 and 1?
Maybe 12 and 1, maybe 4 and 3,
6 and 2.
maybe 6 and 2. The truth is, there's absolutely no way to know which one's the right one without making a guess and trying. Oh, this is going to be fun. All right. So, which one do you want to pick? 12 and 1,
2 and 6.
6 and 2, 2 and 6. All right. So we're going to try 6x and 2x. Those will give me 12x squared, correct? Now, on the other end, I've got to multiply two numbers together, and I've got to get a
Positive.
positive 6. So how can I get a positive 6? 1 and 6, or 3 and 2. Which one's the right one? There's no way to know. You've got to guess, and you've got to try. Which one do you want to try? 6 and 1? 6 and 1. Now you just have to see if you can make it work. And what I mean by make it work is, this gives me 12x squared. On the end, I would have 6x. And here I would have 12x. And then a 6 on the end. Is there any way I can manipulate the signs so that the 6x and the 12x will give me a negative 17? No. So what does that mean?
It's wrong.
It means it's wrong. The other question is, what's wrong? Is it the 6 and the 2? Or is it the 6 and the 1? Or, even worse, do we simply have them in the wrong order? What I mean by that is, if I put the 1 here and the 6 there, when I do my multiplies, I'm going to get different numbers in the middle.
This sucks.
This sucks. I agree. All right, so the moral of the story is, you don't want to guess and check, do you?
No, not really.
No.
There's a different way to do it.
Teach us, Master.
I will teach
I
you.
need to scare her.
All right,
I
so
just said I'm already having trouble with these.
now I will tell you, I have seen students who have excellent number sense and can see things in their head. I have seen many, many students who can look at this, guess, and almost always get the right answer the first time. However, that's not most of us. I'm not good at doing that. That's not how I factor. Here's what you do instead. The guess and the check works, but it can take a long, long time till you happen to guess the right answer and make it work. So here's what we're going to do instead. We're going to take 12x squared minus 17x plus 6. We're going to multiply the two numbers on the end. We're going to take 12 times 6. 12 times 6 happens to be the number 72. That's correct. What you need to do now is you need to factor the number 72 so that the numbers add up to be the one in the middle. Negative 9 and negative 8 will work. Negative 9 times negative 8 does give us 72. 9 times 8 is 72. And negative 9 minus 8, those add up to be negative 17. Here's what we're going to do. We're going to go back to our original problem. We're going to write the 12x squared. I'm not going to write the negative 17x. Rather, I'm going to write minus 9x and then minus 8x. And then finally, I still have that plus 6 on the end. Are those the same? Did I change anything really? All I did is I took the negative 17, I wrote it as minus 9 minus 8. Still negative 17, correct? Now what?
Take your common factor.
Okay, what's my common factor?
1,
No.
2, 3, no. 4.
How many pieces do we have now?
Three.
How many pieces do we have? We have
4.
we have 4 pieces. 1, 2, 3, 4.
So we do the 2 and 2.
So now you do the pairs. That's correct. This is called grouping, factor by grouping. This is exactly what we did last time. Once we have 4 pieces, we do it in pairs. So we take the first pair. What's common in the first pair? 3x. And left over? 4x minus 3. What's common in the second pair? 2? Negative 2. Excellent. Why negative 2?
Because it's negative 8.
If the term in the beginning is negative, we're going to factor out a negative. We're going to take out a negative 2. What's left over? 4x minus 3, because minus 2 times minus 3 gives plus 6. Again, you know you're doing this right if those two things are exactly the same. So if you forgot to switch the sign here and you wrote 4x plus 3, and over here you get 4x minus 3, that should tell you you made a mistake. You got to go back and fix it.
Yeah, I'm just a little confused with earlier. How did we get the 72?
We multiplied the two numbers on the end.
Okay.
12 times 6.
And that's what we normally do.
That's what we'll do every time. Yep. All right, so final answer. What's common now? 4x minus 3. And I take that out. Left over is 3x minus 2. So I have a question for you. Is this easy?
It can be.
Not real easy would be my answer.
Yeah.
But what's the advantage?
That tree.
It gives you the right answer the first time, every time. Where if you were back here guessing, well, not only was 6 and 2 wrong, 6 and 1 was also wrong. All of our guesses were wrong. We should have been using 4x and 3x, and then we should have been using 3 and 2. We might have been guessing for a good 10 minutes before we happened to hit upon the right combination.
I guess it's easy in regards comparing it to the guessing game.
It's easy in regards to the guessing game, but probably harder than everything else we've done as far as factoring goes would be my response. All right, let's pick another one. How about 3m squared minus 22m plus 24. Okay, here's my thought process. I see the word factor. When I see the word factor, what's the first thing that I should be thinking of?
All these numbers.
Greatest
Greatest common factor.
common factor. So when I see the word factor, the first thing I do is look to see, do I have a greatest common factor? The answer is no, unfortunately. Next thing I do is I count, and I notice I have 1, 2, 3 pieces, and I notice that this first number is not the number 1. If this first number is the number 1, I'm just going to go right ahead and draw my parentheses and put a 1 outside. It's easy to figure out. If this is not the number 1, I multiply the m's. Oh, and this is a funny example. I didn't plan on this. 3 times 24 happens to be 72. 72 isn't the answer for every problem, by the way. I just happened to pick 2 problems where you get 72.
That's awkward.
We'll do another one where you don't get 72. Okay, so now, can we split up the number 72 to make the 2 pieces add to be a negative 22?
4 and 18.
18 times 4 is 72. So it has to be negative 4 and negative 18, I think, to get negative 22. And negative 4 times negative 18 does give 72. So I think that's the right way to go. So you might be working with your calculator there a little bit. You might be taking 72 divided by 2, 72 divided by 3, 72 divided by 4, until you happen to see the right pair. Little work on the calculator there. All right, so we come back, and we write 3m squared minus 4m minus 18m plus 24. We take the negative 22 and we split it into those 2 pieces. Why do we want to do that? Because now I have 4 pieces. Now I can use my grouping. That's exactly right. First group. What's in common? M. So I take an m out, left over. 3m minus 4, very good. Second group. I don't think 4 goes into 18.
Negative 6.
Negative 6 will work. Negative 6. Left over? 3m minus 4. Once again, I notice these things match perfectly. I'm very happy. I write down the 3m minus 4. Left over is m minus 6, correct. Questions on that one? All right, let me try one where I don't get the number 72. How about 12x squared minus 27x plus 15? What would you do?
12 times 12.
You forgot the first rule of factoring.
Oh, greatest common factor.
First rule, oh, you sure?
3 or 3?
3. The first rule is always look for a greatest common factor. And there is one here. And that's so easy to forget. You get locked into one thing. It's really easy to say 12 times 15. You don't want to do that. Take the 3 out. Take the 3 out. What's left over?
4x squared minus 9x plus 5.
4x squared minus 9x plus 5. Now, when there's a GCF, here's what I like to do. I'm going to write that GCF down, and then when I get all done, I'm like so. But I like to take this 4x squared minus 9x plus 5 and go off to the side and deal with it. Otherwise, it can be confusing as to what do I do with that 3. Just put the 3 down and leave it there. Go off to the side and do the rest of it and handle it that way. I think is much, much easier. Well, here's the big reason we want to take out the GCF. If you didn't take out the GCF, what's 12 times 15? Happens to be 180, but you use your calculator to do that, would be my guess. When you take the GCF out, you only have to multiply 4 times 5. 4 times 5 is 20. So what's the advantage of taking out the GCF? Makes your numbers a lot smaller, makes the arithmetic a lot easier to do. 4 times 5 is 20. Can I break up the number 20 4 and 5. And I think it has to be -4 and -5 to get that -9 in the middle, and to get a positive 20. -4 times -5 is positive 20. All right, so we're going to have 4x squared minus 4x minus 5x plus 5. 1, 2, 3, 4 pieces again. With 4 pieces, what do we do? Michael?
When we ended up with 3 and then 4x squared minus 9x plus 5, can I just break it down right the way we were doing it before? 3 and then I could do 2x. And do we have to do it this way?
Well, your other...
Because I'm looking at the 3 and then I look at the 4x squared minus 9x plus 5 and I just want to put it and break it down one more time.
Well, if you want to break it down one more time, yes, you could. But my question is, up front, are you going to use 4x and 1x? Or are you going to use 2x and 2x?
I did 2x.
So you took a guess. And maybe your guess is right, but maybe your guess is wrong. And that's the problem. When this first number, when you have 3 pieces, 4x squared, 9x, and 5, when this first piece is not the number 1, I highly recommend doing the grouping method. Usually you'll get the answer more quickly than you will guessing and trying. All right, so back to our group here. 4x squared minus 4x minus 5x plus 5. What's common in the first group?
4x.
4x. And left over? X minus 1. Very good. Second group?
-5.
-5. Left over?
X minus
X minus 1. X minus 1s are common. Take out the x minus 1. What's left over? 4x minus 5.
Now I put the 5x first, like 4x squared minus 5x minus 4x plus 5.
And you got the 4x minus 5 came
Yes.
out first, and the x minus 1 came out second. Does the order matter?
No.
No, not at all. All right, so I'm going to come back up here, fill in my answer. I've got an x minus 1 there, and a 4x minus 5 there. There would be my final answer. Questions on that one?
You just move up one more side.
Yep. All right, my last example. 6x squared plus 2x plus 5. How would you factor 6x squared plus 2x plus 5?
There's no GCF.
There is no GCF. Good, you checked for that. Then what?
6 times 5.
You multiply the ends. 6 times 5 is 30. How can you break up the number 30 to make them add to be 2? You can't. Why not?
Doesn't work.
Because how can you break up 30? You could have 1 and 30,
2 and 15.
2 and 15.
3 and 10, 5 and 6.
3 and 10, and 5 and 6. So I'm going to write all those down. 1 and 30, 2 and 15, 3 and 10, 5 and 6. Is there any of those that you can use to get a 2? No. So what's the answer? The answer is prime.
I like those.
And you said something about every question on this paper you're going to give us is prime?
No, I did not say that every
Oh,
question on this
okay.
paper I'm going to give is
I
prime.
think I misheard.
You misheard. When the answer is prime, the grouping method is much, much better than the guessing method. If you were doing the guessing method, what would you have to do? You'd have to try every single combination and show that none of them work. And that would be frustrating, wouldn't it? To have to try about 10 different combinations to have none of them work and write the answer as prime. We're here, when the answer is prime, you're done in about 20 seconds or so. And you know you're done, you know you got the right answer. Questions?